Okay, this is our last test video, if you would, and I'm not going to call it, anything more than that, but we'll go ahead and use it. And what we're using it for is to introduce, or reintroduce, I would say, many of you to the concept of parametric equations. And you're going to see parametric equations. And the key word we're looking for here is really parametric. You're going to see equations, you're going to see design, all kinds of different things coming at you. And I know every time we hear equations, we think, oh, equations, relationships. Relationships between two things, specifically, classically taught early or throughout your basic engineering as everything is a function of time. Right? Everything is a function of time. And later on you're going to see, so time is going to be the parameter that determines other things. And classically we're going to go and look at, as you'll see probably in your calculator book that came with your calculator, the concept of a 2D kinematic equation when dealt with in parametry. Now, I'm going to take this time to introduce us in the third semester, but probably even earlier, to the fact that as we start laying out our coordinate system on every sheet of paper we work on, whether or not we really need it or not, you're going to see me very often not putting x and y, but putting x and z. Z being up and implying that y then goes into the board, and then time 0 is at some point, is at 12 o'clock or at the start. So I've laid out a coordinate basis for x, y, z, basically a time datum, and also eventually pressure 0 is absolute, and we're probably losing the board, and temperature 0 is, and I'll put Kelvin here. And we're not dealing with pressure, we're not dealing with temperature. I'm putting it there so you can start getting acclimated to this concept of anytime you're measuring something, you are measuring a physical quantity, it is off of some datum. Some datums are made up. 0 degrees Celsius is kind of a made up number. It's a nice one because it is the temperature that water freezes at its standard temperature and pressure, but it isn't anything that implies a zero state of energy. Same thing with pressure. 0 atmospheric pressure, 14.7 pounds per square inch above absolute zero pressure. The true datum is absolute zero pressure. Quite often, really when you get thinking about it, for x, y, and z, or where you are in a coordinate system, is always going to be some assumed 0 because we are in a very, very big space, being whatever, the universe. All right, so what are parametric equations? Basically, they're equations where each and every quantity is a function of time, and then you can solve or remove time from the equation to put one thing in relationship to the other. So the classic equation I will put up here is if something is leaving with a velocity of v at an angle of theta, where will it be at time t? So you want to determine where it is at time t. And so what you have to do is you have to realize that basically you're going to keep track of where the x is and keep track of where the y is at time t. Well, x will be where it starts, x at time 0, plus the initial velocity at time 0 times the time t, plus 1/2 a, if it's a constant velocity, 1/2 a t squared, when we're talking about constant acceleration there. In other words, it's not accelerating, it's not decelerating. Or it's not accelerating more, I'm sorry. In this case, it's just going to fall out. So we'll take a look back at that in a second. I'll just finish this out. Y is the one you're used to changing more often, equals y naught plus v naught t plus 1/2 at squared. But we have to realize that these are vector quantities, and so this v naught in the in the y direction, v naught in the x direction. And if you know v naught in the x direction, v naught being the velocity at the time 0 or your initial time, it's going to be v times the cosine of theta is what v naught in the x direction is, and v times the sine of theta is v naught in the y direction. You can eventually, when you go through this, you can get rid of time and just have x in relationship to y, and you would have then a parabola. If you think about this falling out, this acceleration, a equals minus 9.8 meters per second per second. And as you play this back through, it will give you a lot more rich data than if you just had the shape of the parabola. Why? It gives you the shape, and it gives you where is the position of the thing at any given time. So, the concept of parametric equations is one of the settings on your calculator. That's all I kind of want to cover here, and we'll go through this problem or point you in some place that you can use. This is a great problem to stick in your calculator and leave it there, because you're going to see not only are you interested in I've done all this, let's spot the error as I've laid this all here, and it's going to be something we're going to try to break out of. You see I've done everything for x and y here, and that's